Okay, so what this problem is we're going to solve the trig equation sine 2x equals cosine x, and we're going to look for only the solutions between 0 and 2 pi. Well, this is going to use the identity, which is a good one to know. The sine 2x is equal to 2 sine x cosine x. So that's a really good one to know. Let's put some box around that or something. And all right, so we're just going to put that in here. I mean, it's sort of the point of doing this problem, but anyway, we're going to replace sine 2x on the left by 2 sine x cosine x, and then that equals cosine x. Now, what you do not want to do is you do not want to divide both sides by cosine x because, and cancel, you don't want to cancel cosine x. And the reason is, so when you cancel cosine x, you're dividing by cosine x, and you cannot divide by 0. So, but the problem is that cosine x could be 0. So therefore, we should not cancel because we're not allowed to divide by 0, and cosine x could be 0. And so what we need to do then is bring everything to one side through subtraction, and then we need to factor. All right, so I have cosine x is equal to 0. That's one possible solution. 2 sine x minus 1 is equal to 0. And this then gives us sine x equals 1/2. It's maybe, to me, when I'm explaining it, it's a little bit difficult that I'm using the variable x. Theta might be a little nicer, but anyway, here I go. So I'm going to draw a unit circle to do this job here. And on the unit circle, when is cosine equal to 0? Well, at pi over 2, I have 0, 1. And at 3/2 pi, I have 0, 1. Okay, pi over 2, I have 0, 1. Remember that cosine is the x-coordinate. And at 3/2 pi, I have 0, -1, and then that means that cosine 3/2 pi is equal to 0. Okay. When is sine x equal to 1/2? Well, see, I'm already using x and y here, and I use x twice, so that's a little bit of a problem. I almost feel like just leaving that x and y out, which some people think is not good to do that. But this is the second coordinate. Sine is the second coordinate. When you look at any point, you're going to get the first coordinate is cosine, and the second coordinate is sine. Now, when do I get 1/2? Well, say something like right here. That's about halfway up. Actually, that's not even quite true. I can just look, because the thing is I have the graph, and I can see that the 1/2 is more like up here. So if I'm probably can't even do that without, no. Anyway, so 1/2 is more like up here, and going along, matching 1/2 is rad 3 over 2. I know that just from memorization. And so that corresponds to pi over 6. So this is sine of pi over 6. So sine is the second coordinate. But also on the other side, I have negative rad 3 over 2, 1/2. And the reference angle is pi over 6. And therefore, this is 5/6 pi. So therefore, I have x, well, starting over here, x equals pi over 2 for cosine x equals 0. X is equal to 3/2 pi. X is equal to pi over 6. And also x is equal to 5/6 pi. Sometimes I wonder about, what's the nicest way to display all this. Maybe I should put it from least to greatest and write it in a set notation, put those special parentheses for sets. So this is the solution set. And, well, I hope I did that right. So that's it.